Right. This is the last case of this strain energy. In case we'll study the what will be the value of stress that is generated in case of impact load. See what it will be. If this weight, if this weight is if we apply this weight from this height to this bar of length L, then what will experience? There will be some elongation in the length of the bar, and that elongation will be let us say this length. It will not be this much, but I drawn it just for the convenience of the students, right? So in this case, the formula of strain energy is equal to half into stress, half into sigma I square upon E into A into L, right? And whereas the formula of this is the standard formula, that is sigma I square upon twice E into A into L, and whereas the formula of strain energy is work done in straining the bar. And as we can easily see, work done in straining the bar is W is equal to W into H plus delta L, right? And if we again in this also, we cannot write down delta L as P into L upon A into E. You cannot write down this. So delta L we have to write down in this case as sigma I because it is a case of impact into L upon E, right? So W into H plus sigma I into L upon E. This is the formula. And sigma I square upon twice E into A into L. Right? And if it is so, now there are two cases in it. In one case, if we ignore delta L in comparison to H, then I can very easily compare it. Sigma I square upon twice E into A into L is equal to W into H, and sigma I is equal to twice W H E upon A into L and understood. Sigma I. That is the formula I got. And in second case, is sigma I square A into L upon twice E is equal to W into H plus sigma I and A into L upon twice E minus sigma I into W L upon E minus W into H is equal to 0, and this is a quadratic equation. In case of sigma, this is a quadratic equation of sigma I, and if we solve this equation, we'll get this value: P by A plus minus under root P square by A square plus twice P H E upon AL. And if we compare this further, we can take this P by A outside plus minus P by A 1 plus twice, where P is equal to W, right? Adjust in this expression, P is same as W. P is equal to W. So twice PHE upon AL into A square upon P square, because we have taken P square upon A square outside the bracket in this equation. That is why I written it like this. So A cancel this cancel, or P by A bracket 1 plus minus 1 plus twice AEH upon PL. So this is the formula in case of impact load. This derivation sometimes comes into your theory questions, right? Thank you.